All right, so then when we're looking at this second problem, so we're just going to just pick one of the methods that we're going to use. I like to use the slope and y-intercept on this type of problems just because it seems pretty easy. So same process is we're going to solve it for y. So subtract x from both sides, and then we will divide everything by 2. So this is the same line, so it should actually get graphed the same way. So we have our y-intercept of 3, and then from there we're going to go down 1 over 2. To make our line. Now, what we need to look at when we're talking about inequalities, so if we have things that are not equal to, so greater than and less than, those are going to be dotted lines. Greater than or equal to, less than or equal to, those are going to be solid. So when we draw this line, because this is just a greater than symbol, then we are going to make this a dotted line or a dashed line. Okay, and so then the other thing that we have to think about is this needs to be shaded. So because it's an inequality, it's going to be a range of solutions, not just one solution. So we're going to have this shading. We're going to shade top and bottom parts of the graph. So what we want to do is we want to read this sentence. So this is y is greater than negative 1/2 x plus 3. Greater than is going to be shading above. So we're going to actually shade the top half of this graph. Now to check ourselves. So we've done our shading. It's good to check yourself. So what I can do is I can pick a test point. I like to test 0, 0 just because it's an easy point to plug in. And so essentially what we're going to do is we're going to plug 0, 0 into our equation. And we're going to see if it makes a true statement or an untrue statement. If it's a true statement, it should fall in the shaded part of the graph because that means it would be a solution. If it is not a true statement, it should be in the non-shaded portion of the graph because it is not a true statement. So if x is 0 and y is 0, and we want to see if that's going to be greater than 6. So 0 plus 2, 0 is going to be 0. And we have this sentence, 0 is greater than 6. 0 is not greater than 6. So that is an untrue statement. So that would fall in the non-shaded portion of the graph because it is not a solution. And so what would happen is if we picked any points in the shaded portion and we plugged them in for x and y, we should get a true statement. One thing to note with that is because this is a dotted line, the points that are actually on the dotted line would not be solutions. Okay, and so dotted line is stating that the points on the line are not part of the solution set. And if it's a solid line, then they are part of the solution set. All right, so let's go to this next one. So for purposes of just practicing, let's make a table on this one. So we have 2y plus 3 equals 11. So let's say if we have an x value of 0. So we have 2y I failed to put the x. There should be an x there. Okay, so 2y plus 3x. So 2y times 3 times 0 equals 11. So that means 2y equals 11, and y is 11 over 2. 11 over 2 is 5.5. So we're going to go 0, 5.5. Then we could go 1 and go through the same process. So plug in 1. 2y plus 3 times 1, which is 3, equals 11. Minus the 3, you get 2y equals 8, so y is 4. So 1, 4. Let's try 3. I think this way is a little bit more time consuming, in my opinion, which is why I don't usually, this isn't my go-to way to do it, but I want y'all to be exposed to kind of different methods. So 2y plus 9 equals 11. So when we subtract 9, we get 2. So y is 1. So 3, 1. And then we can just draw our line. So that's that one graphed. Okay, so same concept over here, except we have an inequality. We already know points on the line, but just for the sake of doing it another way, let's solve for y here. So let's move our x over. So 2y is less than or equal to negative 3x plus 11. Divide everything by 2, and we get y is less than or equal to negative 3 halves x plus 5.5. Okay, so we go to 5.5. This is a little trickier because it's a decimal, but we're going to go down 3 over 2. Okay, this is an equal to. So because it's equal to, we're going to draw a solid line. And then we need to do our shading. So this, if we read this, we read it y is less than or equal. And if you notice, we know that it's less than because if you look at the less than symbol, if I were to pop that up, it would be an L. So that's an easy way to distinguish between greater than and less than. Less than is going to imply that we're going to shade below the graph. Okay, so we're shading below and we have a solid line. So to check ourselves, we could plug in a test point. So if we plug in 0, so the point 0, 0, so 2, so let's say 2 times 0 plus 3 times 0 less than or equal to 11. So 0 less than or equal to 11. That is a true statement. So because that is a true statement, 0, 0 should fall in the shaded portion of the graph, and it does. So we have shaded correctly. So that's inequalities. Here is one more that we're going to do that's a word problem. Carlos estimates that he will need to earn at least $700 to take his girlfriend to the prom. Carlos works 2 jobs as shown in the table. So first of all, it wants us to write an inequality to represent the situation. So he has 2 jobs. One is $8 an hour, one is $6 an hour. Okay, so if we take his 2 jobs, so $8 per hour. So let's figure out, first of all, what our variables are going to be. So what we don't know is we don't know the number of hours he works at the deli, and we don't know the number of hours he works babysitting. And those are the 2 things that we need to find out. So when we write our inequality, it's $8 per hour at the deli plus $6 per hour babysitting. And we need that to be at least $700. Okay, so at least means it can be $700, it can be more than $700, but it can't be less. So we want that to be greater than or equal to $700. And then we're going to graph this. So subtract our 8x. You know, and in this case, because these numbers are so big, it actually would probably be easier to do an x and a y-intercept in this case. So let's say for x-intercept, our y is going to be 0, so we're going to have 8x plus 6 times 0 greater than or equal to 700. So 8x greater than or equal to 700, divide both sides by 8. So we have 87.5. Now, on our graph, we have really big numbers here, so we probably need to go probably by tens instead of ones. Okay, so if we're going by tens, if we have an x-intercept of 87.5, then we could say that this is 10, 20, 30, 40, 50, 60, 70, 80. 85 would be in the middle. 87.5 would be somewhere close to 90. Okay. Then for our y-intercept, we'll have 8 times 0 plus 6y greater than or equal to 700. So now we'll have 6y greater than or equal to 700. So y is greater than or equal to 700 divided by 6. So that's going to be about 116.7. Okay, so we only went to 100. So let's make another one that would be 110. And this is going to be 120. So our graph here is going to be somewhere closer to 120. And then we could draw a better line than I did. Okay. Now, one thing to think about is this should actually not go past these end spots. And the reason is because this is a real life situation. And if we go into the negatives, what we're talking about is we're saying that he worked a negative number of hours, and that doesn't really make sense in this case. All right, so then we want to do our inequality. So if it's 8x plus 6y is greater than or equal to 700. So we could do a test point. So if we test 0, 0, we have 0 is greater than or equal to 700. That's an untrue statement. So that means 0, 0 should be in the non-shaded portion of the graph. So this should be my shaded portion of my graph. So the next thing it asks is, will he make enough money if he works 50 hours at each job? Okay, so 50 hours at each job is going to be right here. And it looks like it's right on that line. And so if it's on the line and it's a solid line, then it is a solution. So he should have enough money. And we could check that by plugging 50 in for x and for y and seeing if that is greater than or equal to 700.